Okay, so I said that there are 3 different rules that we need to know. We just talked about the first rule, difference of squares. Now we're going to talk about the last 2 rules, two-factor and simplify expressions. So what's different between this one and the ones that we just did, like this guy? There's one main difference. Notice that this one is x squared minus 16, x cubed plus 27. A big difference is this cubed, right? Now I'm working with cubes. So before we were looking for perfect squares, right? 16, the square root of 16 is 4, okay? I need to now do like the square root of 27. Now that's not a thing, right? The square root of 27 doesn't exist, but what does exist is the cube root of 27. So we need to go through and make sure that we know our cube roots. So I did the first few. You want to jot these down. 1 cubed is 1 times 1 times 1, that's 1. 2 cubed, 2 times 2 times 2, that's 8. So take a second to pause this and simplify the rest of these cubes. So hopefully you just pause this to simplify the rest of these cubes and take a look. This is what we should have gotten. And what we want to point out now is all of these are what we call perfect cubes. So we want to become familiar with these numbers, okay? So now when we go back to do this example, x cubed plus 27, I have 2 different options. I can do the formula for difference of cubes or the formula for sum of cubes. There's only one correct form. Which one do you think it is? For this one, we're going to do sum of cubes. Why we're going to do sum of cubes is because we're looking at the beginning part right here. Which one doesn't match? I have x cubed plus 27, so that's why it has to be sum of cubes. We're going to set it up the same way with this skeleton formula. What cubed gives me x cubed, and what cubed gives me 27? So the first one's easy, right? X cubed gives me x cubed. And then what cubed gives me 27? I could take a look back here. Let's bring these back. What cubed gives me 27? Oh, perfect. That's just 3 cubed, right? So I can go here. 3 cubed gives me 27. Here's my A, here's my B. I go ahead and plug in for all of my A's and my B's. Okay? So I'll underline here. I'll have a plus b in my first factor. So that's going to look like x plus 3, right? My a is x, my 3 is the b. And then I continue. I have a squared, so I'm going to write x squared minus 3, which is my, really, that's my b, right? Oh, I'm switching colors. 3 and my a is x. So really it would be written like x3, but that's not really a good way to write math, right? We usually write 3x. So minus 3x plus b squared. My b is 3, so I would write 3 squared. I can simplify 3 squared, and that's how I get 9. Okay? And there is my factored form when we are dealing with cubes. Okay? So let's do another one together because it takes a little bit to get the hang of these. So let's do this one. X cubed minus 125. So which one is it going to be? Difference of cubes or sum of cubes? Difference of cubes. We know it's not difference of squares, right? Because I have a cube. I'm going to set up the same skeleton here. So what cubed gives me x cubed? X. And what cubed gives me 125? So I go look at my list. What cubed gives me 125? Just look in here. 5 cubed, right? Take a look here. 5 cubed gives me 125. So I could write 5 cubed. And then once I have my a and my b, I'm going to go ahead and put it right into this equation. Okay, here's the equation. And I have x minus b which is 5. My b is 5, so x minus 5. A squared, x squared, plus ab. My a is x. My b is 5, so it would say x5. We want to write that as 5x in my final answer, plus b squared. My b is 5. 5 squared simplifies to 25. And that is how we factor when we have cubes. Okay, so now you can use this video to do the difference of cubes and sum of cubes in the practice. Awesome job, guys.